before we start, I know that going online for the next at least 3 weeks, and everybody has something else going on at their house and all of this stuff. I need you guys to, everybody's going to state one good goal, not related to school, that they're going to do for these 3 weeks. Something that you feel like you are going to accomplish. Set a goal. Take a couple minutes to think about it. I'll give you mine, and then it could be anything that you want. So I have two now that we're going to be at least 3 weeks at home. First, I stopped painting this last year and a half, so I am going to do at least one painting a week, and I'm going to exercise outside at least once a day, like actual exercise outside, not in my apartment, outside. Okay? So for the next 3 weeks, those are my two goals, and I need you guys to at least say one goal not related to school that you're going to do these next couple weeks.
Trying to gain weight up to 80 kilos. So that's like 3 more kilos in like a few weeks.
Gaining muscle, hopefully?
Yeah, muscle. Like, because the gym didn't close. It's like, if you have the vaccine, you can go there. And it's also like the spa, so yeah.
Perfect. Mm-hmm.
Learn the guitar.
Oh, are you going to also use that for your cast project?
Yeah, I talked to Mr. Shino about it. I'm learning Where's My Mind by the Pixies right now.
Oh, that's excellent. Who's your cast supervisor?
I don't have one yet. I can't use my family, so I might say Mr. Hume or something. I just need to
ask Mr. A, and all you have to do is send him like video clips of your like progression.
Yeah, I'll ask him then.
Okay. Yeah. All right, ladies, what do you got for us?
I'll say it's same for me. I want to learn how to do music, and I wanted to ask Mr. A to be my coordinator, and also because we're going to be at home the whole time, so I want to start like working out, maybe do some yoga to maintain physical activities.
Excellent, those are good. Mm-hmm.
Yeah, I also have like a similar thing. Well, I haven't been like going outside of the house for the past few days, so I like want to like actually leave the house, like have a goal to actually like get outside at least once a day, not to be like stuck at home. And maybe also like find a book to read or something like that to like get of the like electronics for a while. Yeah.
I agree. Yeah, I find myself just stuck in the house, so yeah, definitely getting outside is good. Yeah. Perfect. Okay, so let's get started. I'm going to share my screen. Okay, so if you see in the class notebook, today's goal is I really just want to see what you guys know from 2.1 to 2.2. This topic is pretty short. We're going to do a little carousel activity, a little electron configuration review, and then we're going to discuss what we need for next class, and that has to do with the homework that you guys had. All right, so is everybody on Teams right now? Yep, okay, perfect. So in Teams, and I'm going to put you guys into breakout rooms. In Teams, if you see where I am, there's under topic 2, there's this collaboration space. So under the collaboration space, again, there's another thing called topic 2. You're going to click on that, and you should see this sheet here. Tell me when everybody's here. When everybody sees these different colors. Put a thumbs up so I know. Max, let me know when you're there. You're there? Yes, Max? You're muted.
Okay, so I opened the class notebook, and now I just feel like a vegetable. I can't find anything.
Okay, so your class notebook, there's this...
Okay. Okay, I found it. Yeah, okay, I found it.
Okay, so what I'm going to do is I'm going to put you guys up into 2 breakout rooms, and then the first breakout room will start with number 1, Dalton's atomic theory. The second breakout room will start with Thomson's Plum model, okay? I'm going to give you 3 minutes. Basically, it's like a brain dump. You're going to tell me everything you can that you remember about Dalton's theory, his postulates, his laws, his significance, and you should be able to type in here. So if everybody can right now just type so I can just type in, like make sure that everybody can type in there. Can anybody not type? I see hello and toe. Say toe. Okay. So that was 3. That was 2 of you. 3 of you. One more. Everybody? Yeah. Okay. All right. So you're going to use the collaboration space. You're going to go in there. I'm going to give you 3 minutes, and then I'm going to broadcast an announcement that says go to the next one. Once you go, and you just keep going down. So, and you are going to do these only as much as you can for 3 minutes. It really is just a brain dump. And then if the group before you wrote something, then obviously don't repeat it, right? Something else. Okay, do not copy and paste from the internet. If you need to look at your textbook or your notes, that's fine, but you only have 3 minutes. So basically, I just want to see what you know. And you're going all the way, starting at Dalton, and you're going all the way down to the QMM.
I'm trying to use not the exact words.
If it's like a postulate or law, then you can use the same words.
Okay.
Yeah.
Indivisible and indestructible particles called atoms.
Yeah. Okay.
The second one is atoms of the same element are exactly alike. They have the same masses.
So atoms of the same element have the exact same masses.
Yeah, you can write that. They have the exact same masses.
It's Chadwick in 1932.
Nice job.
And he used a cathode tube to establish.
No. They just say he had an epiphany while eating plum pudding. Yeah, that's good.
Okay. Okay. What's the most significant?
Name the model after his favorite dessert.
Oh, they wrote something like make a model similar to his dessert. I guess that's very similar. Okay, we can just read that. Name the model. The plum pudding model. Well, there was something where he later on was his model was rejected. Very similar.
Yeah, his model was proven incorrect. I mean, I think they already said it was disproven.
Correct. Oh, he said the electrons were scattered unevenly, and he what was another thing he said that these charges were surrounded by positive charge to balance the electron's charge.
Are we on Bohr's model now, or no? It was the Ford's.
You should have moved. I guess you missed the broadcast. You should have moved on.
Oh, I didn't even see the message. Oh. Okay, we can
Number 3 then.
Refer for his
He oversaw the Geiger and Marsden carrying out the famous experiment.
No, the refer one was the one with the gold foil. I think.
Yeah.
Yeah. So he basically oversaw Geiger.
He fired high-speed alpha particles.
Okay, I'm gonna add this. Particles into
What was that? Was it a good way to review it? Yes, no?
Yeah, I know.
I know.
It was fun.
It was fun, huh?
It was something else, so it was alright.
Okay. So as I'm looking through it, I see that there's some key parts missing in each of them. And before we go over it, what I want you to do, and this is for homework tonight, I'm going to assign each of you one of the 5. Okay, and then I want you to go through and really make it through. So like Dalton's atomic theory, there's definitely parts that are missing there, as well as Thomson, and so there's definitely key facts that you're missing. If you look at your textbooks, it's page 38 to I think 49. They really go through, and it's pretty concise. It's a page long that just goes through each. So what I want you to do is I want you to go in and fill those blanks, the things that we missed. I'm going to stop sharing my screen for this, and next, we're going to review everybody's favorite, electron configuration. Yay!
I kind of wrote it out on my periodic table so I don't forget them.
You don't forget. Okay. So what we're going to do is I'm going to give you an element, and you are going to type it into the chat. But you don't press enter until I say enter. So we all press it at the same time, so that you have so that you don't copy over the person above you. Does that make sense?
Yeah.
Okay. So let me show you how to write it, because you can't write the subscripts. So let's do lithium. So lithium would be 1s2, 2s1. And write it like this in the chat. Oh, Max, you want to write it like this? It's faster. And just put a comma in each. Does that make sense?
Yeah.
Yeah? Okay, everybody has the periodic table out?
Yeah.
Okay, so let's go through the first one. And I already have them pre-selected, so let me get to my page where I have them pre-selected for you guys. Okay, the first one is neon. Neon. And don't press enter until I say. Thumbs up when everybody's ready? Clara, are you ready? And enter. Okay, so Maria, absolutely correct for the shorthand. And Max, you can't just write neon like that. Sorry, dude.
Okay. I thought you could.
Correct for the shorthand.
So do we need to write like both ways or just one of them?
You can just do the longhand for right now. And Fetchy, you need to put in the 1s2, not just the valence electrons. Okay? Next one, you are on, it's a long one, not too long, calcium. And again, put thumbs up so I know that you're done before you press enter.
Potassium, right?
Calcium.
Oh, sorry.
Yep, I just put it in the chat. How's that? Calcium. You guys all good? Okay, enter. Oh, Betcha, sorry, I didn't see you shake your head no. Max, you gotta write the long hand. Okay, next up is the shorthand for gallium. Shorthand for gallium. Okay, so let's just quickly, we're gonna quickly talk about describing the electromagnetic spectra. Okay, and like when I say quickly, I'm gonna mean quickly. And EMS, okay, is how we're gonna do it. So let's talk about the visible light part. So I'm just gonna draw, we have red here. What do we have next? Then we have orange. Come on, you can do this with me. After orange, we have yellow. After yellow, we have green. Then we have some blue in here. And then everywhere else in real life, you have indigo. And I think that's just because science is like 7. I'm not going to put the indigo in there. We'll put this little purple in there. Okay, so right there's our visible light. And you guys know this. You know the order. You know all this. Okay, so let's talk about your actual spectra here to know that we go over it. So here, all your spectra is basically just a graph, right? So, okay. And tell me about what we see here in my wonderful drawings, okay? Tell me anything.
That the higher frequencies are more towards like purple and the lower are more towards red. And there's only a fixed range of frequencies that we can see.
Yep, okay, so high frequency is here.
There's also the like wavelength goes from right to left, so like from purple down.
Yeah, so it's really big over here, the wavelength. And you remember the lambda sign for wavelength? Yeah, it's really big here, and then really small wavelength here. This, like you said, would be your visible. Max said you could only see part of it. What would be over here then?
X-rays and stuff.
Yeah, so it goes all the way. You have your UVs are all the way out here, and then your IR, which is your infrared, is over here. We're missing one important thing. When we talk about this, what do we also talk about? It starts with an E. We have really, really, really high energy over here. And we have low energy over here. This is kind of what you have to know. You do have to have the order, and you should have looked in that, and it's also in your data booklet. You guys all have your data booklets at home?
Yeah.
Yeah, okay, good. It's also in your data booklet. So, and the questions will more likely ask, which has a higher energy or higher frequency, IR or visible light. They'll ask these type of questions. And you just have to look at you just have to know that it's high wavelength, low frequency, low energy here, and then over here, small wavelength, high frequency, high energy. That's it. It's as easy as that. Questions? Okay. Okay, so I think that was pretty easy. We're there. And now, okay, in the chat, I just dropped you a link. And what I want you to do, I think it's like a 9-minute video. I want you to turn your cameras off. I want you to watch it, take notes on it, do whatever you need to do. And I'm going to give you about I don't know, 10 to 12 minutes to watch it and take notes on it on the video. And then we're going to come back and we're going to discuss everything in it, okay? Okay, are you ready? I'm going to put the first question up. Okay. What are the ways to add energy to an atom?
I do just write it.
Hold it up so I can see if you are correct. Maria, perfect. Perfect. Bridget, perfect.
See.
That's one. What are the other two?
Okay.
I say, how many are we supposed to write? Like one?
There's three.
Oh.
You got it, Max. Mm-hmm. Perfect. Yay. Okay, next question. Easy. True or false? Electrons can exist between energy levels. Good job. Good job. Perfect. Perfect. Well done. You know, you guys can unmute yourselves. There's only 5 of us. Okay. What does it mean for an electron to be excited? Max, you gotta give me more. Be more specific. Maria, perfect. Okay, that's good. Okay, that's good. There's one, you guys have the basic part. You're missing one important part. Let's wait until Max. Let's see if Max hits on it. Go down. Vibrating. No. Okay, so you know it needs to jump, right? But where does it have to jump from?
Like a lower to higher energy.
Yeah, so that's the key part. To be excited, it has to jump from a lower energy to higher energy level. Okay, so to be excited, Max, what does the electron have to do?
It has to jump to lower energy.
Yeah, so it has to move from a lower energy to higher energy. And what are the 3 ways that it can do that?
By getting energy from heat, electricity, or light.
Perfect. Well done, well done. Okay. Here's an easy, hopefully this is an easy one. What is released when an electron jumps back to a lower energy level?
Energy.
Write it. Perfect. Max, look again. Good job. Clara, good job. Good job, Maria.
All right.
You probably saw it, right? It's a photon,
Photon,
right?
yeah.
And what do the photons correlate to?
Light.
Yeah, so these photons, you know in those light spectra where, you know, you had these little spectra? I don't have red. I might have red. No, that's a blue pen, not a red pen. Okay, so those photons are what are producing these spectral lines. Okay? We're going to skip it. Does anybody know that these spectral lines, they're actually called the fingerprints for atoms? Okay, so these are the fingerprints for atoms when you have these spectral lines here, like we were shown in the video. So anytime that you have these, they're going to be unique for that atom, right? So it's pretty neat. Like we have our own fingerprints, the atoms have their own fingerprints, and they're seen with these photons of light. Okay, next question. Do electrons jump in steps like a ladder? Do they go from the first step to the second step to the third step? Okay. Good. Good. I'm getting dizzy from Fedja. Good. Okay. Can they, if they wanted to? Can it go from 1 to 2 to 2 to 1? Can they jump in steps? They can, but they don't always have to. Yeah. So they can. I think of it as my own children, right? Do you guys know, like when you're walking up the steps, or you guys at school, nobody ever just goes step by step by step. I watch you guys. You go like step here, you skip this one, you go here. If it's really crowded, then you walk every step. Okay. But it's the same with the electrons. Can you see my teams or no? Yeah, okay. All right, so in topic 2 here, I added today, I was going to have you guys do a FET lab, but I asked the students last year about it, and they said it was awful. They didn't learn anything. They just wasted their time. So I'm glad they gave me that feedback, because I'm not going to make you guys do it this year. Okay? They said the lab in class was amazing, but we can't do it, so I'm sorry. So what I added today, I added all of the SL vocab for you. Okay, so those are words that you have to know. And I also put it in a Quizlet for you, so you can test yourself. But this is all the vocab for the SL part. I also put in your test review. So these are all my typed up notes, so I typed them up for you. And then use a textbook's answer key I gave you. Here are review questions and for paper 1 and paper 2. And then this just has hundreds and hundreds, well not hundreds, but it's really a mega pack of past test and questions and answers. So those are for you guys to study the SL section. Right now in class, had we been actually in physical class, I would have had QR codes set up all over the school where you and a partner go around and connect to the QR code and then answer the questions. I'm sorry, but we can't do it like that. So in your collaboration space, you're going to see, so Max and Maria, you guys are going to work together, and Claire and Fedja, you're going to work together. And so here, I'll just go to this one. These are the cards that you would have used in class, that where the QR codes would have gone to. And there's quite a lot of them. So what I want you guys to do with your partners, you can either annotate it by just using the draw tools and writing. I am like really, really bad at this. And I'm like really slow. I'm trying to spell my name, but I can't even do that. Okay, you can either do it that way, or for me, I like to just add a box in there. Let me go somewhere where I can do that. Hello, and then I just drag it to where the answers are.
Miss, how do I find the notebook on the desktop version?
On the app? It still should be, it's not on the side.
No, on the desktop, the
app, yeah.
The web thing.
Share your screen. I'll stop mine. Share yours and I'll help you.
It should be the exact same way as the website.
That's fine.
I just feel blind.
I can tell you don't use it, and I have so much information in there.
It's like.
Okay, so you have to go to where it says Teams. All the way
Oh, wait, never mind.
Okay.
I feel dumb.
Okay, so I'm going to split you guys in your breakout rooms, and you're going to work on those questions. I think
Why are these questions so complicated?
they're the test questions.
No, it's just I'm bad with definitions.
Yeah.
Okay, an atom is made up of a nucleus and electrons.
Okay, so the
Positively charged
yes.
nucleus. Can we just leave two blank and then it works? Made up of a positively charged nucleus composed of protons and neutrons.
It's one of those words that are always in every question. It's dense.
Dense?
Dense, a dense nucleus. Yeah.
Another H is 1 and like another one is 2. Okay. In the periodic table, it's like okay, I don't know English, I'm sorry.
Okay, so we just.
Wait, which one?
No, Z is a big number, right?
Z is your atomic number. So Z is the number of protons.
Okay, small number. Oops. You haven't seen anything this. We are pro chemistry.
I'm pretty sure what that means, but okay. Yeah, and A is your atomic relative mass.
Yeah, so I just.
That should be, yeah, there you go. The other group is really struggling with anything. And even the questions, it's very strange. You guys are doing okay though.
Yeah, I just like to draw.
Yeah.
Okay, so let's find the term isotopes of an element. Okay, so.
I know that you're stuck on this one. I'm going to share my camera. Okay?
How did you know? No, I mean, I understand like the process, but there should be like a given amount of percent abundance, like different for each of the isotopes.
Yeah, so this is where IB is different from your regular chemistry. So they told us, you guys can see the screen, right?
Mm-hmm.
So they told us that K39 93.3%. Then they told us that K40 is X. Well, they didn't tell us, but I'm assuming. I'm just making it up. It's X.
Okay.
And then K41, what would K41 be then?
Why?
We don't want two variables. So I know that these together must equal what? The percent?
6.7.
Yeah, so together they must equal 6.7. And you got that by how?
Well, like 100% minus the 90%.
So that's all I'm going to do here. I'm going to say 100 minus 93.3 minus X. Does that make sense?
Mm-hmm.
Okay. And then the formula for relative atomic mass. So, I answered, but I want you all through the rest of you three to answer. Was this helpful? Should we continue this next class and then you don't have to do any of it on your own?
Yeah, I think this is more efficient.
It was fun.
Yeah.
Okay. All right. So we'll continue this next class. What I highly suggest is you look at the questions in the book, you look at the vocab. I gave you all of the answers, so do the work and then check your answers. We'll keep going over this. I don't want the SL to take their test before you know it, and I don't want to move on to the HL until you know the SL material really well.
Well, we have like separate tests. If,
It's
okay.
not do a separate test, yeah.
Miss,
Yes, sir.
I don't know physics, and there's like physics questions. Is that also going to be on the actual exam?
Yeah, they're not physics questions. They are the electromagnetic spectra questions, which is also chemistry.
Mm.
Yeah.
It's the most
It sounds more like physics though, but okay.
Okay, guys, I know that your time is important to you guys, so class is over in 30 seconds, so I don't want to hold you on anymore. Please feel free to email me or chat if you need anything, okay?
Mm-hmm.
You guys have a good weekend.
You too. Bye.
Bye.